Hey, what's going on? This is Kyle. I just wanted to take a quick second to record my explanation of IWAN to hopefully make it clear that I can portray what this technology encompasses and what its capabilities are at a range of audiences. So I have a whiteboard here and I'm going to try to go through it again, so bear with me. Okay, so first off, let's talk about what makes up IWAN. So IWAN is really just a marketing term because there's nothing really new in it. It's just it encompasses a collection of technologies. Those technologies, I'm just going to spiel them off and we'll go over them. DMVPN, Dynamic Multipoint Virtual Private Network. So if you're familiar with GRE tunnels, you can figure out DMVPN. We're going to have IPsec, QoS, specifically DSCP markings, VRFs, and last but not least, PFR, performance routing. So I'm going to just leave this here on the left-hand side, and we're going to draw just a simple WAN connection between your data center or your main location as well as a remote site with a traditional, and we'll kind of see how these technologies fit in and what IWAN might look like. So say we have your data center 1 and we have remote site. And say you're probably going to have, because it's a critical remote site, MPLS1, MPLS2. You might have Verizon and AT&T, but you're going to be dispersed. Just make sure that if one provider goes down or a colo died, that you don't lose both. You have a router here. Here's your WAN routers at your main location. You need connectivity to different MPLS providers. So this is probably what you're doing today. And how do you manage this? You're probably running, this is your CE routers, and these are your PE routers. You're likely running BGP. I prefer BGP if I'm going to do a routing protocol for this piece, BGP, so that I can have a little bit more control of my outbound and inbound routing. You might have different subnets to make sure that you don't have an active and standby. You might have certain subnets that you're preferring over certain paths. You might say in PLS1, I'm going to AS path prepend on these subnets. In PLS2, I'm going to AS path prepend on these subnets to control which path they take. And then vice versa, you're going to do local preference so that for certain prefixes to your main location, they take a one path versus the other. That's all fine and dandy, but you really don't have the most granular levels of control. And for failover, you're completely dependent on BGP's failover. This path needs to become unavailable for me to even consider the alternate path. So, all right, now let's jump right in. What is IWAN, and how does it fit into your existing, or how is it different than your existing architecture? Ooh. So let me erase some of this stuff here. We're going to keep MPLS1, because that's typically your hybrid model, and most people are more comfortable with keeping an MPLS provider, which is okay. So here's what would be, I just wrote MPLS2 again. INET. Now what does INET mean? INET is going to be your commercial internet. What's the benefits of using a commercial internet versus an MPLS? It's probably a lot less expensive. I've seen T1 connections for hundreds of dollars, whereas you can get a 50 meg down, 10 megabits per second up for, under $100 for a commercial internet connection, business class connection. So now that we have this set up, pretty much going to look, you're like, this looks like almost identical, except I have INET versus an alternate MPLS provider, which would be correct. But the difference is that now that we have these connections, we're going to basically build a DMVPN tunnel across these providers. What does that mean? That means our transport is agnostic. I don't care if this is AT&T. I don't care if that's level 3. I don't care if it's a Cox Business internet connection. I'm basically tunneling over it, saying I'm just using them as a transport. I'm tunneling over it, and I'm encapsulating that with IPsec. So even though I'm going across the commercial internet, they have no visibility of what I'm sending. All they'll see is IPsec. So now that I have this connectivity, you're okay. Now I have DMVPN. I'm really still not very different than your traditional routing. Instead of peering with the provider, I'm sending it over my tunnel. The way this is different, truly, is that in your hub, you're going to have a master controller. What is my master controller? And what is IWAN and what is PFR? Because all this is where it starts tying together. What you're doing is basically saying you're looking at your network through a different lens. Instead of being the road on which everything drives, you're going to start looking at what applications go across your network. You're going to say, what are my mission critical? What are my delay sensitive, be it voice or video? What is the crap I don't care about? Now what we'll basically do is, first thing we're going to have to do is identify what those things are, and once we've identified them, we'll create policies on our master controller that are pushed down through our network, so that when traffic arrives, and this is just from a high level viewpoint real quick, if I have a phone here, when it arrives on these routers, it'll make a forwarding decision based off of delay, latency, and loss. These are things that before were impossible. You had different mechanisms to, your SLA with your provider to ensure that those were true, but if for whatever reason they fell out of your tolerable limits, you had very little other control other than calling the provider and saying, hey, what's up? So what we'll do is we'll create policies on our master controller, and using PFR, or performance routing, to say, when I land here, the router will already know, hey, say this is my HSRP active and this is my standby. This router will already know, am I using my MPLS path or using my INET? And what we'll do is we'll build out policies to say, under perfect conditions, MPLS is my preferred and then INET is my fallback. And we can do different policies for different application profiles. So for, say, our mission critical, like say we have Exchange and Citrix, we would consider mission critical. I can build a policy that says, INET's my preferred and MPLS is my fallback. And furthermore, instead of MPLS and INET, you can go INET and INET, because again, we don't care about the transport. We're building policies, and INET is just a label. We can have 4G connections that's only used when everything other path is unavailable. So, what do you gain by this? You gain by the fact that you have redundancy on redundancy, being that you can have multiple transports that, again, our overlays really doesn't care about. So let me go a little bit further just to kind of explain how some of these work, and if you have any questions, you can always hit me up. So here are our remote BRs, our border routers. So I'm drawing these lines to indicate that we have different VRFs. This is called front door VRF. Now, what this allows us to do is to have multiple default routes. And typically this is more important if you have a single BR, but for two, we'll do it anyways. Because what we'll be doing is when we build our tunnel, we want our outside edge, be it MPLS or even internet, be it internet or even MPLS, we want our outside edge to be completely separate from our overlay that goes across it. So when we build our tunnels, it's using that outside VRF to get that connection. But if you're on that outside, you have no connection to go anywhere by yourself. So if for whatever reason we had an attack come across, if it landed on a router, it would have no path to go anywhere. And in addition to that, if you're in a scenario where you have a single BR that has an MPLS and an INET connection, The reason we have that front door, we have a different front door VRF, let me try to make that a little bit more clear, for both connections is because we want to make sure we have a default route for both of those. And when we build our DMVP in tunnels, we can reference both VRFs independently of each other. Because we want to make sure that route knows, if I build a tunnel and referencing this VRF, he knows to go to the MPLS, and if we build a DMVP in tunnel using our iNet, he knows to build that tunnel I have to go out using my commercial internet connection. And in that VRF, the only thing you'll see is that connected interface that goes to the internet, and a connected interface goes to MPLS. But the same thing works if we're doing dual routers at our BR. You know, and the main reason you want to do this is a critical site. You don't want to have a single router that's a point of redundancy. So you have two routers and run some sort of FHRP, be it HSRP or VRRP or GLBP or something like that. You know, but HSRP works just fine. So, you know, that's kind of how all these things kind of fit into each other. You know, the last thing you're probably looking at is I still have QoS. You know, we've talked about these applications. What does that really do for me? Why do I need QoS? So, you know, most engineers, like I said, they hear QoS, they kind of cower. Well, you know, being that the main platform for this is going to be your ISR 4331 or even the ASR 1002, 1003, etc. What we can do is use NBAR. And if you have any experience with NBAR, you're like, okay, I can match on Citrix, I can match on Exchange or something like that. Well, the current generation of NBAR is ridiculous. You can use NBAR to match on World of Warcraft, Call of Duty. You can match on, you know, very, very specific applications. And the options are much more allowed, you know. But the thing, you'll still have to, you know, use layer 3 ACL for matching if you're doing any sort of, you know, homegrown applications that NBAR doesn't know about. And you'll just use MQC, which is thankfully the better type of QoS configuration, to do basically what's called a markup at here, 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 and here. Now, what I'm saying is, as the traffic goes from your remote to your data center, you have to make sure that it has the right QoS value, so when it lands on to my border routers, it knows how to handle that traffic. Because again, remember, we have a traffic that says my delay sensitive. What it's really doing is saying the DHCP values of EF, for example, when it gets to me, what policy do I have for that? And I would say, oh, my EF traffic is delay sensitive. That is preferred MPLS as long as it's less than, you know, 20 milliseconds of latency and has less than 2% loss